We're going to start off with tin model volumes. And for those of you that this is the first session you've had with me this week, I ask a lot of questions, I talk about random stuff, and I try to teach you as much as I can. I apologize for that, but that's just my style of doing stuff. We're going to spend some time in PowerPoint this morning or this afternoon, and then we're going to jump out. At any point, if there's anything that doesn't work for you, just like the last session, stop me and say, this doesn't work for me, or I don't understand what you're talking about, or you're full of gibberish. Certainly interrupt me. It makes for a much easier way to conversation. I need a glass for my soda, and we'll get started. How many people use tin model for volumes? I asked this earlier. We're going to talk about the volume portion of it now. We talked a lot about tin model in the last session. That's because it's supposed to be tin model. And editing and doing things in tins. Now we're going to talk about how to get your volumes out of tins. How many people use cross sections and volumes? And how many people do beach volumes? In the volume folder on that thumb drive you were given, all three presentations for those three different topics are in the volumes presentation. I'm getting better, even though it's hard to believe. It's time to start my first soda of the afternoon. All right. Put that back down there. Tins, we talked about tins, tin model volumes, create a triangulated or regular network. And then triangles are created between X, Y, and exact points. There's no gridding going on in the tin model, and the exact volume of each triangle is computed. So in this particular case, the blue rectangle represents the flat surface that's calculating the volume against the level. And you can see that the white three-dimensional shape that's drawn there is what would be calculated as the volume above that flat surface. That makes sense to everybody? Where you can see the flat surface, the blue line, cuts through the triangles at that point, and all of that is calculated as your volume. Making a tin model, we've already talked about this. Checking it for voids, adjust your tin max side. Anyone need me to go back over that? I think I beat that to death in the last session. Make your tin model, check for voids, make sure they're not there. Adjust your tin max side until you get something pretty. Then you can go in and actually cut out all the bad triangles. Modifying editing, tin, we all did that. So, tin to level. When you're doing a tin to level, you're generating a file that is, you're going to generate volumes between slices through your tin at different levels. The volume above and volume below. Does anyone know what the volume below is in a tin to level? It's a void. So imagine a bowl. We've got a big salad bowl. The top of the bowl is 0, and every inch down the bowl we're going to cut a cross section. The first inch down the bowl, I've got the volume of material that it would take to fill that top inch of the bowl, right? The volume below is how much material it would take to fill the bottom inch of that bowl. So if I put a bowl full of dirt, that top inch of dirt is the volume above the first inch, right? That makes sense? The volume below is what I got below that if I had the template for the bowl. If I don't have a template for a bowl, I would have to have the shape of the bowl down there. If the bowl was empty, how much water could the bowl hold? Am I explaining that right to everyone? You have a pretty good idea what I'm saying?
All right. When you run the tin to level tool, you're only going to get an output for the volume above the level.
You'll get a volume below if there's a void.
Okay. So it'll give you both numbers. So long as you have a surface.
So if you have a surface,
Yeah.
and it's got, we're going to do a model of it in a second,
Yeah. Go ahead, just keep going.
but it will give you a volume above and a volume below.
Right.
The volume below will be 0 if
there's no surface.
it's solid material at that elevation. Does that make sense? There's a lot of examples. In our tin model presentation, there's a project for tin model, and you'll see this SSS.xyz. that it gives you the files and the steps to reproduce what we're going to talk about. So we can actually step out and do some of these samples in a minute. I just want to talk about, like I said, about how the tin model works. Everyone understand how to make a tin? Most of you were in the previous session. I don't want to go back through stuff that we already talked about if we can skip ahead. So tin model volumes, tin to level, you set the scales that you want. I want to go from 1790 to 1850 every 10 feet. And it's going to generate those every 10 feet. And you'll see it's not necessarily going to equal the same number at every level. So the material above and material below is not going to be the same because your area footprint changes. Does that make sense? I had this question recently where somebody was doing a tin model and they said I did tin to level, and my tin at this level, if I added tin above and tin below, didn't equal my tin above and tin below added together at the next level. What they weren't understanding is as you went down, the area changes, right? Because the slopes come in, so that level isn't as wide as the level above it. So you can't just say, I should have 2 columns and my answer at the end of the columns added together should always be the same. They won't be. Don't follow that? It was an odd question and I never thought of it in the way he was talking about it, but it's really important to understand. In the new tin model program after 2016, we have the ability to generate a PDF of your tin model volumes. I haven't used the PDFs very much, but it's an option. The second thing that I want to talk about really quick, when you do a tin volume calculation, that checkbox right there, show picture. Does everyone know what that show picture does? It slows your computer down doing a volume really much. That's what it does. And the reason it does is when you look at these are the pictures it's going to draw. So it's running along and it's doing a tin to level, and it did this and it draws that picture. And then it does this and it draws every one of those triangles on the screen every time. So every level it's going to erase and start over and draw, and it takes a long time. If you don't show the picture and you just want the volume, it's going to spit out a number really quick. So here's a tin to level. The report comes out, cubic yards, tells you all the information. It's kind of similar to when I talked about the raw file. There's a header at the top of the report. And then it spits out your numbers here where you have the tin level, volume above, area below, area below. And that's where I found the answer to the guy's question, why don't my 2 columns match up? Because your areas don't match up as it got deeper. Actually, I had to think that one through, which is kind of silly now that I think about it. Right? So your areas, this is volume below is the volume of the, when they say volume of the pool, it's the volume of the void that you would have water in if it was an empty space. Okay. Any questions about that so far? We're doing okay? Sir?
Maybe the dumb guy in the room, but I'm still not tracking why your total area or your total volume wouldn't be the same above and below.
So, if you look here, see that area that's the void? The area at this level, if you add the numbers up, so you're at the top level, right? You're right here. If your channel comes in or your volumes come in like that, your area of that 10-foot gap, the top and bottoms of that area are sloped in, so it's a smaller area. It doesn't cover as much of the land because you have, based on the slope, you'd have a smaller void. So as you go further down, it's not the entire tin. This right here is the area at 1810. This blue area is all that counts. Does that make sense so far? But 1820, the blue area is all gets counted over there. So more area gets counted as volume above as I go deeper because it's more material that's going to be above that volume. Does that make sense?
But you had said that the area below the line and the area above the line doesn't always equal the same volume.
When we add, if we look at right here, where's the area? not sure, because now I'm confused. I want to look at it again. But the areas, the two numbers added together don't equal the sum on all the same lines. The areas, though, when I look at these and do the math quick in my head, there's 941,000 and 352,000. So that ends up being about 1.29. And that number here is 1.29. So, but if I look at the volumes, the volume here is let's see, 18 million. No, 1.8 million. And the volume down here is 500. No, that's area. Volume. So that's 587,000. That's 53,000. If you add those two up, they don't equal that. But if you add those two up, they do equal that. So it's the volume you can't add together, not the areas. Sir?
And the area is square feet, right?
Yes.
Okay.
So Christian usually gives this lesson. And in the first 10 minutes, I've already got a mistake. We're doing good. Rob, edit that out. Your question is valid that when you look at the areas, if I add that area and that area and that area, they do seem to match. So the areas should line up. It's the volumes that don't match up. Everyone understand my mistake? Everyone forgive me for it? Come on. All right, tin to level report. This is what your PDF report is going to look like when you do the tin to level. So each one of these is your levels, right? And then you intersect your lines. This dark line looks like volume above, volume below. And then you have your areas. Area above, no. Volume below, area below, area above. So this is area below, this one's area above, and that's volume and that's volume. That's why the two actually look at it. The two areas start off on opposite ends and end out the corner, so areas do line up. That's what the PDF report's going to look like when you do a tin to level. How many people do tin to level volumes?
I do it for surface area.
For surface areas?
Yeah, and I think if you load a channel file, you can actually select only surface area.
Okay. So let's go. Let's see if I have the. This is the one that's got all the files in it. All right, so we're going to do a practical example just to talk about border files. You can limit the areas with a border file too. So when you're doing tin to level or any of them, you can actually bring border files in and it'll give you the volumes within that border. Anyone ever do that? Sir? Okay. So you can have different border files and it'll actually give you the report based on that area. When it does your volume, instead of just saying, you know, your tin above and tin below, you'll actually get line item information. Let's go. What am I supposed to be on here? We've got our model, calculate volume, level, this is one, this is file. So you can come in here and you can say, where's my border? Multi-select, shift and click. So hold them all up. And we have 1750, 1850, 10. One of the newer things in the last couple versions of tin model is now we have the check boxes to include volume above, include surface area above, include volume below, and surface area below. So you can uncheck those if you don't want them. It's kind of nice to clean up the tin model volume. Show the picture first. That took half a second to calculate my volumes. Exit, and then we can go view report. And you can see in here, now I've got, at this level, each one of my border files is broken out. Volume above, area above, and the numbers for each section that the border file is encompassed. It's a nice way to break things down. If you do a CHN file, which we'll talk about, you can have zones, channel zones. This is a way of doing channel zones without a CHN file or areas. Any questions on it? Okay. Practical example, we did that, came up with answers. Single level vertical direction. If you're in elevation versus depth mode, your numbers just reverse which columns they're in, right? Volume above becomes volume below because you're looking at the opposite direction. We just did that. So this explains why clipping your XYZ file before you do your tin is bad. Because if you clip your XYZ before you do the tin, you won't have any data at the edges, right? At the edges of your XYZ file. If you clip the data, you might underestimate the volume because you're going to eliminate points that would have been outside of the area you care about. Does that make sense so far? If you clip the data within tin model or limit your volume within borders, it's actually going to give a border volume right up to the edge of the border. So if you've got data outside of the border, you're going to get a better volume than if you clip the XYZ data beforehand.
Where do you clip it? What example?
If you have an XYZ data set from Multibeam and you clipped it in the shell, you went in there and said, I only care about this data, give me an XYZ data inside the border. Or if you use the border files in the volume example I just did, the volume example is going to give me a volume right up to the edge of the border.
Right. Or also, if you go into edit tin and then open
Trim.
the border file and trim it that way, it gives you the same volume, right?
Right, it trims it right to the edge of the border. This is exactly what you were just talking about. And here, if you clip modify edit tin, use the scissors and cut your surface, it'll cut a model exactly along the edge and it'll generate points along that edge so that you have right up to the edges of the border. Everyone follow what we're talking about? That way if you trim it in the edit mode like we talked about earlier, you're going to get a more exact area. Any questions? This gives the best volume results right here. Which would be the similar to if you use the border file. Don't take pictures of me. This is if you use the border file in that volume section. I have not to run the program right now because last time he walked in, it crashed right in front of him. But if you're in here and you're doing a volume, this is going to happen behind the scenes. If we loaded those 5 border files like I did a minute ago, the same thing is going to happen as if you trimmed it with each one of those border files individually. It's just going to happen behind the scenes. So that's how your volume gets calculated.
It's nice to have it in the report too when you load the border file.
Yep.
And, it's nice to be able to see which border file is exactly you use.
I like it by doing it the way you're talking about, where it breaks it out line by line by each border file, because then I can go back, and if one of my guys is helping a customer, we can go back and look and see what one did they use versus what one we're using. We've caught ourselves telling a customer an answer, and they were using a different one on their computer than we were using on ours. So here's an example of where they went in and they trimmed it, put a couple border files out. Tin to level is pretty self-explanatory. In here they were limiting them with the border files, and you can see in the report, similar to what we had before, they only used one border file, but at each level it tells you the volume and the area for that particular border section of the border at each level. It makes a messier report. It's not as clean as some of the other reports, but it gives you more information. So now we're going to talk about tin to tin differences. Anyone have a question on tin to level? There's a lot of questions, not a lot of questions, a couple of questions earlier in tin model about tin to tin differences. You have to have two surfaces. It's really good to determine where you've lost material or gained material. On dredge projects, especially hopper dredges, when they're moving along, they plow through the material, and sometimes the material moves, right? Because they're missing it up, and then it goes downstream a little bit or whatever. You end up with material that moved within the survey. So you can actually do surveys, and it'll give you the difference between what the two surfaces look like, and it'll actually calculate, because tin to tin is going to give you the volume difference between the two surfaces. You'll know how much material is infilled. That's the point behind it. The color-filled section right here is the sample I used earlier, the 3x3 and the 10x10 for everyone that was in the earlier session. Light green to blue is material that grew. It got more material. Yellow and orange, which I don't know why they put yellow as a, well, I do, because yellow is hard to read, but yellow and blue on the screen and orange are where we lost material, so we had migration of material. So when we do that, we have to bring in two different tin files. You have to have two different surfaces. And here we're using the X pre and the X post. 25-foot max side. Everyone remember what a max side is? Okay. We make the tin and then we export it. In this case, they did a grid difference and then colorized it. If you use the node, use an XY difference point at each node, or if you use a grid, that's where we're going to define. Earlier we defined a 5x5 grid that was a nice evenly spaced grid. Nodes are the actual XYZ points or XY points. In the color model in here, you set your color bar, plus or minus whatever you want, because you're no longer going to, let's say you had 50 feet of elevation, you're not going to have 50 feet of elevation, you're going to have plus or minus a foot or two, right, of material that came or went. So you're going to change your color file to match that. In this particular case, they did plus or minus 15 feet. Everyone understand how to adjust your colors, right? We're not going to go through that basic part of it. Net accumulation or loss. You can calculate the volume differences, and let's go through. We'll select the X pre, X post, check what the second tin looks like. You can see they modified it a little bit. Calculate volume tin to tin. Let's remove all these borders. Took 0.4 of a second to do that. It's because I have a super fast computer. No, it's because the data sets were small. Export, view report. Anyone ever wonder why I have a volume report on top of a volume report? It's because I didn't exit tin model. So you know that. So here we have at the bottom tin 1 above tin 2 and volume of tin 1 below tin 2. So tin 1 was my pre and tin 2 was my post, right? So that volume is the material that moved. That's how much material was moved from what it was originally. Tin 1 was the pre, so if it's above tin 2, there's a void between the two. The material moved out of tin 1. And then the volume of tin 1 below tin 2, I gained almost 15,000 yards of material. I lost 5,000 yards of material. So we have infill from somewhere. Right? Sir?
Did you use a Word file with this one?
I did not.
Okay.
I just used the straight up data set. And I did that because I wanted to see the actual numbers that came out. So volume of tin 1 was only 6,000 graph.
And that's helpful because it shows exactly an X, Y, where it's at.
So we're going to step out of the slides for a second like we did earlier. We're going to talk about an improvement in the future. It'd be nice to be able to just generate that difference in 3D color map without having to do anything. Where you could actually select, like I can select tin 1 or tin 2 here. It'd be nice to be able to select differences here too. Right? Because I can select tin 1 by unchecking tin 2, or I can select tin 2. But if I could check differences, then you wouldn't have to go generate the difference file, exit the program, enter the program. Okay.
Thank you, that helped out.
That explain everything to everyone, what we were talking about with differences and where material came from and went to. And I say this in every session, we really do care about the things that don't work for you. We are trying to make the software better. So things like that, we just identified a step that we don't have the display that we should have. We should add that display in. So it's something that I can talk to the programmers. Please make sure in any session you're in, not just mine, interrupt the person giving the session and say, hey, this would be a nice feature, or this doesn't work for me because it's difficult. That's how we make the software changes that we make. We don't just...
Along those lines, anything relating to cut and fill is a common operation. Show me just the cut, show me just the fill. Being able to, like I'll often plot, along with my report, show the line mark to show just where the cut is, or just where the fill is, and if it cuts all red, fills all green, or maybe I just want to show cut, or just want to show fill.
Similar to what we're showing right now.
Yeah, Roger, but having separate files for that, or just having, it depends what the nature of the project is. Just cut and fill tools in general, having versatility makes a lot of sense with bridge pack.
A lot of the stuff we try to do there is with the channel files, what's above and below the channel. Not so much with this, where tin to tin differences, but where we're...
Yeah, for whatever, it's a different conversation, but I tend to use XYZs and not channel files because ease of use,
Yep.
from a workflow perspective, points, as opposed to trying to make a channel file, or bringing in, I brought this up yesterday, like bringing in your channel line work is generally developed by the engineer on the project, not so much you as a developer. It might be bringing in line work and creating a channel file is
All right. It's one of the things we talked about earlier with the DJM files, right? Oh, man.
Who was using XYZs for everything is really easy and snappy.
All right. Well, that's something we can certainly work towards is that we want those tools. We want to add those types of features. Sir.
Is there a way to say
There's not in the 10 to 10 volume because we're computing the differences between the two. You'd have to offset one of the surfaces to the overdip bottom to generate that number.
That's wrong.
There's no way. One of the things that we've talked about in the past, and we've never come up with an easy way to do it, was to be able to say load tin 1, load tin 2, and tin 2 is going to be similar to what you're saying, XYZs of my channel, and then give me the vertical offset to that, and replace the surface by lowering it that far.
Oftentimes you don't want the whole surface, you just want the channel bottom, you don't want the side slopes. You
Right.
pay for side slopes that are below, and that's really common. But your overdrive would only be the channel bottom.
And that's where we would limit those with border files.
Sure. Yeah.
And that's or if you do have a channel file, if you do a CHN file, not tin to tin difference, but tin to CHN. When we get into tin to CHN, we'll check and see if there's an overdredge there.
Can you make a CHN with a variable surface? Like, for instance,
Not for environmental dredge, if that's what you're talking about.
the dredge out that's typical on the line is 6 inches.
Yeah.
Essentially, use 2
You can't. So what he's talking about is, anyone work on an environment, and I'm going to paraphrase for a minute if you just give me a second. Anyone ever work on an environmental job? Environmental jobs, if you're digging a channel and you're the channel guy and you have a channel, the slope comes down, it hits 40 feet, it goes straight across, it goes up. You might have some complex turning basins and things in there. I'm not trying to oversimplify your life. That's one type of cut. What he's dealing with, and we've been doing this for a long time, you take an XYZ file and they'll go out there and take a survey. And they'll say, we're just going to take 2 feet out of this lake. Everywhere in the lake. We don't care what the depth was. So we take the surface and we offset it 2 feet. That becomes the template. So over there we might be taking it down to 14 feet. And over here we're taking it down to 8 feet. But it's not a slope from 8 to 14. It's a variable surface that you're trying to cut out. Environmental jobs are really strict like this because they'll take core samples. The whole Hudson River job. They would take core samples and they said, this is where this bad stuff is we want to take out, and it varies throughout the river. So your template went like this, where your surface on the top of the material was a nice flat bottom, but your template, they're trying to cut this with an excavator as a rolling template. So we developed a way where you can take the XYZs in as a matrix, and then load the matrix in as a template, and then you can cut to that irregular surface. Originally, we tried to load it into CHN files. And if you make a tin of something, you can actually go file, save tin as a CHN. So you can generate a tin of a small area. You can come in here and say file, save. Down here at the bottom, it says tin, INI, or CHN. I could save that out as a CHN file, and it'll create all the faces and nodes and all the things I need in a CHN file. But it creates so many of them that DredgePack or Survey can't handle that big of a CHN file because it's got to create all the nodes and faces and things. That's why we came up with the matrix method of doing it. There's really no easy way to do what you want to do. It's because there's so many nodes and faces. In a regular channel, you think about a channel, your one section might be 300 feet long or 1,000 feet long in a rectangle that is all one depth. It's 2 faces at most. In that same non-linear type of environmental dredging, you could have 50,000 faces. And it's just difficult to generate all those faces. That's why we did the matrix file method. When we go to tin to CHN, like the volumes you're trying to do, we're going to have to add a way to generate that offset, that lower level. There's just no other way I can do it. Well, to simplify it, what I propose, and I'll talk to the programmers about it, would be to add your additional file here, and then have the ability to make an offset from it.
Or, or you just take your estimate.
You have to go in and lower it, but to simplify it from my perspective, if you have your template, and I could give you a 1 foot, like an offset level, just give me an offset level, and then do it for me. Then it would be a temporary offset, and I could play with it.
Overdredge tools would be nice though, in the report, right?
Yeah.
What is the volume of overdredge that you took? Overdredge is almost on every dredge shop.
We have those for, we have that overdredge for cross sections and volumes. But in tin model, you'd have to mix tin to level with tin to tin. Because tin to tin is going to tell you the difference between the two surfaces. The second one is, oh, you're going to get overdredge. It's just not going to be labeled that way. In tin to tin surfaces, your void, tin 1 below tin 2, would be the overdredge.
Right.
In the Philly method, they give you overdredge, right?
Yes, but the Philly method, you can't do tin to tin. The Philly method has to have templates and channels.
Or a channel embedded line file.
Right, so what they're doing is they're trying to do a tin to tin surface on an irregular bottom and actually calculate, so we have that, we have 2 feet of, we have a lake bed, we want to take 2 feet out, and you can go 6 inches below that, so that lake bed bottom is going to vary, so you can't really make a CHN out of it,
Right.
but you want that 6-inch number. It's an interesting problem that I'll take back and talk to them about. I have a good idea what's going on, but you are correct, and you can do it in a couple of the different methods, just not tin to tin. We talked about the display I had on the screen a little while ago with the green colors. Volume above, volume below. Net gain was 8,000 yards. Remember I said we had about 15,000 of infill and 5,000 of loss? Net gain was 9,000 yards of material. I don't know where it came from, but it came there. Eliminating scallops. We talked about this in the single beam, or in the volume class a minute ago. 10 model class. Earlier we talked about eliminating the scallops with the single beam data. Remember there was the check box to align your 10 model with the single beam? For everyone that was in the 10 model class, we talked about that. For everyone that wasn't there, the reason you do it is, in this example, we have files that we can use. Tin max side, Philadelphia method. Without adjusting it for the single beam data, there's 1,900 yards. Adjusting it and getting rid of those little triangles that it's talking about, you end up with 3 cubic yards. Has to do with Delaunay triangles and all the stuff we didn't want to talk about before. Any questions about that? Eliminating scallops? Nope. Going once, going twice. Gone. Does sound like an auctioneer? Come on. All right. What's going on? And this is what's causing it. It's hard to see, but if you don't eliminate the scallops, you end up with the triangles like this, and each one of those is going to add material. And once you eliminate those scallops, you don't have to worry about the extra material that doesn't exist, and it has to do with the way the contours are created. So in here we have the real world example, and then the Delaunay result, which is the normal tin model method, which creates that extra length, which creates the extra material. You fix it by checking that box, which we just talked about. Philadelphia method. How many people use the Philadelphia method? Anybody here from Philadelphia? The Eagles fan? I'm just kidding. I'm from Detroit. My team's got a quarterback with a broken back, so we're good. All right. So the Philadelphia method was written specifically for them, as it says. Why do we have a Philadelphia method? Because they paid for it. Anyone ever go into volumes and wonder why there's so many drop-downs of volume types? You would think that volumes are volumes. There's only so many ways to calculate how much dirt is above my line. But apparently there's a lot of them. That's why we have different methods. So using the Philadelphia method, you have to have a before dredge XYZ or log file. You might have an after dredge, and you have to have a line file made in channel design. You bring all that into tin model, and you can do the Philadelphia method. And it's got a whole bunch of stuff on the right here that it talks about. Computes the area and volumes between the lines, subdivides them into different parts of it. You can quickly change the channel depth. This is one of the key features of the Philadelphia method. You're in the Philadelphia method and you want to dredge your channel to 40 feet. That's your channel. How many people adjust their channel depth based on the amount of money they have for dredging? The Philadelphia method lets you say, how many cubic yards can I take out? Well, I can only take out a certain amount, so let's see what dredging at 38 feet would have done. And adjust your methods. That's my understanding of what the great features of it is. Contour, non-contour over depth. We didn't talk about contour and non-contour yet, and I don't know how much time we have going on here. We got plenty of time left. Oh yeah, we got plenty of time left. Contour and non-contour. Do you guys understand what that is? We're going to talk about that in a minute because I want to make sure everyone else understands it, the people that do. You can do that in the Philadelphia method. Tin and L&W slope versus a box. Philadelphia method lets you adjust box cuts. When you're dredging, a lot of times in the slope, you just want to dredge into the slope and assume the material will fall in. The Philadelphia method accounts for that. Contour, non-contour. This is what I wanted to talk about. So contour over depth. If there's material before and material after. If there's material before and then there's material after, you get credit for the material. See, the material before was above the template, and then down here the material is not above the template. They dredge this out, so you get credit for dredging that because there was material above it, above the template. That makes sense so far? If there's pre-dredge material above the template, you get credit for things that were over-dredged. If there's no material above the template and you dredge between the template and the over-dredge, you did it for free. You don't get paid for that. Everyone understand that? That's contour dredging, contour over dredge. Non-contour doesn't care. Contour over dredge will only pay them for that amount of material. If you're in contour over dredge, you have to have material above the template or you shouldn't have dredged there. Now, this is a pretty bad example because the original survey was below the template and all that infilled above the template and they didn't get charged for it or get paid for it. Cross sections and volumes and tin model volumes both have a contour setting for Philadelphia method. Any questions about that? We talked about tin model volumes now for about 45 minutes. We're going to finish a couple things and then we're going to jump over to cross sections and volumes. How many people are here for cross sections and volumes? I don't want to spend my whole time on tin model. Sound good? So, when you export the Philadelphia method, you can do left, right, center. It'll break them down into the zones for you. You don't have to have advanced channel design zones. It'll do them for you. Okay? Channel depth and over depth in the Philadelphia method. This works both in here and the other one. If your original channel is more than one depth along the center line, this option will be entire channel specified depth. So if you set this to something other, you want to change it there, you can adjust your over depth there, and then it'll rerun the volume report for you. So you can adjust it in the tin model volumes part. You have to rerun the volumes each time though, right? It doesn't just update the number. And then it generates this report. Everybody has their own type of way of looking at numbers. So this is the Philadelphia report. Total pay removed, total infill, pre versus post, It gives you all the information on it. All right, tin versus channel. We'll go through this real quick just to talk about. Did it twice. So in advanced channel design, you can actually generate some pretty complicated designs. That's in Kuwait, where they're building a bunch of islands and houses on the islands. That's an actual channel that somebody designed. Different steps in your advanced channel design. Rules for making faces. Everyone know how to make an advanced channel design? A CHN file. Let's not talk about CHN files. Making a simple channel file is pretty easy. Bring that in. So in tin versus channel, here we've made some slopes. So you've got the center of your channel, and then they've got faces out here that are where your slopes are. You can create left and right side slopes and tell it which ones to create, and it'll take those faces or those nodes and it'll generate a face on the outside of them. So you don't have to go in there and adjust your slope. When you do that, you do put a toe depth. So it goes from your channel depth up to the toe depth so that your slope is generated properly.
Shouldn't that have been top of bank?
It's top of bank. They call it toe depth in here. It's top of bank. Zone edge lists. So you can actually create zones. So in advanced channel design, we have left toe, center toe, right toe, and end zone. They created an end zone down here. So you click the faces you want and add them to a zone. When you do your volume, you're going to get, just like we did a volume in the border, a volume in the zone. Right? So when we do this volume, they ran the volume with these files, and we told it what zones we wanted. Include over depth and 2 contour over depth volume. So we have cut, no contour, and contour over depth, left toe, center, right, end zone. Tin versus channel, we're able to tell it that we want contour, over depth volume, include over depth volume. So this is the no contour, this is the contour difference. You can see there's about 80 cubic yards difference based on the contour over depth. It tells you what the difference would have been. But this is what using advanced channel design would give you for your contours, for your zones. The quantity, since we don't have a planned line, it only shows the total for every zone. It doesn't show you the total, the zone per station. Right? If you had lines in there, it would actually break it down for each section. Sections and zones, which is the next thing here. At the bottom here, I don't know if the next slide is going to show it better. No. At the bottom here, it shows me from 799 plus 41 to 799 plus 56, center, left, right, end zone, and then the section total, and then it does it for the next section. So if you had those sections in there, each planned line, it's going to break it into reaches, basically, right? All right, we're not going to go into multi-channel volumes. Anything else in tin model volumes you guys want to look at?
Real quick for the multi-channel volumes, do you just open the channel or hit channel file button and then just select multiple channels? Is that new for 2020?
It's been in there. We didn't have anybody computing volumes in one shot. So what they did is you can load up to 4 CHN files. You can multi-select 4. The routine computes amount of material above each surface. So You can load 4 different CHN files for different reasons, right? Maybe you want to see the pie in the sky if we volume dredge to this template or that template. Similar to what I was saying by in the Philadelphia method, you could step down and see where your money can be spent. Maybe you have 4 predefined settings. We want to go to this. If we have enough money, we'll go to this. If we have enough money, we'll go to the 3rd. And pie in the sky will go to the 4th. And just run them all at one time on the same data set. It doesn't mean that you're going to have a channel here and then a whole other data set with a channel there. If you have one big data set, you could have 4 different channel sections with 4 different CHNs. But I would do that with the border file. So you could have one big data set with 4 CHN files and run all of them at once. Does that make sense? It's going to break it down. Multiple channel inputs, up to 4 channel files. You see here where you load them. Multi-channel Philadelphia method. Seems a little more complicated setup portion of it. I know it's been in there at least a year. And we do have an example of it. Let's see what the report looks like. So you have channel 1, channel 2, channel 3, channel 4. And it's going to give you left, right, center. Yeah. If you offset your XYZ twice, but that's using a CHN file, so.
Right, but it's like create a CHN.
Stockpile volumes. Anyone ever do stockpile volumes? That came out last year. Stockpile volumes is border files. Multiple stockpiles can be measured at one time. We did this for LiDAR data flying over stockpiles in a sand pit. Make a file, border file around what you're looking at, and then you load them and do your stockpile volume, and it generates you have a checkbox in volumes. Check the stockpiles, and it'll actually generate the volumes, the area, and the material in each one of the border files. It's really good for stock. I mean, obviously it's for stockpiles. But
so is it just giving you elevations instead of depths? And like
anything above, what it does, actually, this is where it becomes very neat. The border file becomes a cookie cutter, and then it takes and cuts out the data inside the border file. But at the edges of the border file, it inherits the elevation of the triangles that it cuts, so that your template, your 0 base, is the edges of the cookie cutter. So if the bottom goes like this and your pile material goes like that, the bottom went like this around the edges where your cookie cutter was, that's the edges of your cut, not just a single flat cut. So it inherits the surface at that point, and then you just cut the volumes out of it.
Okay, so you don't have to load it for it takes the elevation at the border.
It takes the elevation at the border, and then it it cuts out that center. It creates a flat surface. It basically tins those elevations, creates a surface, and then does a volume comparison. Sector.
Is that, is it the last couple of years?
2019 is when it came out. All right, that's tin model volumes. It took a little bit longer in tin model volumes than I anticipated, but we're doing okay. Any questions on tin model volumes? It's still logging. Just going to make sure that I'm getting recorded so they can use my voice against me. Just kidding. No, we record all of these so that you guys have them later. And Rob, you guys all met Rob in the opening. He's going to be doing the Q&A in a little bit. He's the MC for the Q&A. He takes all these videos and he cuts out any of the things we shouldn't say or we said wrong, and he fixes them, and he takes them and puts them up on Ustream. And then in about a month, they'll be all done and formatted in a nice way. you can watch all this stuff, because there's no way you can learn everything we're trying to teach you in 3 days, right? We're just trying to give you a good basis on it and give you some stuff and some ideas. Most of the people that attend our sessions have been here before. They get a refresher and they're like, wow, you know what, I remember that, or I don't remember that, or I was wondering how that was done. You can go back to Ustream and you can watch these again. Find out what it is that you missed, or hey, I remember he said this. Go to the one you attended, or what happens a lot, you missed one because you went to another one. You can go see the one you missed. Volumes, event, cross sections, and volumes. Basic terminology. You have the vertical and the horizontal. Here's your survey data. Volume above design, volume in the over depth that's allowable, and then you have a void that would be below that, right? This is another one of those presentations that we're not going to go. There's 146 slides in the cross sections and volume, just this particular presentation. If you want to learn something about cross sections and volumes, this is the slide for you. But I'm not going to go through 146 slides. We can't possibly do that in 30 minutes and actually talk about each one. Get ready to sneeze and nothing happens. Come on. Basic terminology. So when you're doing volumes where you have two surfaces, material above design, material removed and allowable over dredge, remaining material and allowable over dredge. This would be over dredged material, which drives me crazy that there's over dredge and over dredged. Over dredged is material you don't get paid for that you dredged. And then infill would be where the second survey comes above the first survey, where some of the material probably got pushed over because the dredger was swinging his ladder or something. Chainage and offset. Everyone know what chainage and offset is? Distance from the beginning of your channel and how far you're off the center line. Right? Volumes by sections. A lot of times you do left slope. Center line is not always the center of the channel. Sometimes the center line can be offset from the center of the channel. You have left top of bank, center of the channel, left toe, right top of bank. And over there you can see what the sections would look like at that. Rear chainage examples we don't want to worry about. Classification of allowable over depth. There's the contour, non-contour. We were just talking about that, right? So in here, material on the bottom of the chainage, this is allowable in contour, this is not. You can dig in here, but you can't dig over here. Tell that to a guy running the cutter suction dredge. Pick it up, put it down. It's not going to work that fast. Contour over dredge and post dredge, same thing we were talking about before. You can see the areas where this would be material to get paid for. Contour over depth material, you only get paid because the material is in there for the second survey. Post dredge calculations. We're talking about this contour stuff a lot. It can make a big difference. That's why we talk about it, right? So non-contour dredging, if you were to cut, how many people work for a dredging company? So you want to remove every ounce of material in the over dredge because you get paid for it, right? If you're doing a non-contour job and you cut this perfectly with a scalpel, you get 27,000 cubic yards because it's a non-contour job. You get paid for everything. In a contour job, you only get paid for this little bit over here in the corner, and it's 8,000 yards. It's 19,000 yards different. So if I'm paying you, I want to do a contour over dredge. If I just want to get the material removed, I'm going to do a non-contour, right? But it's a big difference in how it matters in some cases. Other cases, you might not have any difference. You could have material above. No over depth on the side slopes. Some methods allow you to ignore some of our methods. you can ignore any over depth in a side slope, but you get paid over depth in the center of channel. If you see that, you'll see the void here where you're not getting paid on either side. It can be turned on and off in most of them. Box cut templates in the Philadelphia, we talked about that in tin model a little bit. They allow you to do the extension. So, how many people have run cross sections and volumes? Okay, for the people that run cross sections and volumes, we're going to talk about it for the next 20 minutes. Is there something specific you want to talk about? Or just an overview of it again? Because I'm going to go through the overview for the people that haven't seen it. I want to make sure I cover it in depth enough for the people that want something out of it. If you have something specific for me to go to. Good to just continue on with this way. I'm not boring everyone to death. Lunch was pretty good. We're not asleep. All right. I'm running low on Diet Coke, so. All right, on the survey tab. The survey tab, we got Philadelphia pre-dread selected, so I've got an over depth. I can put objects in here. I can put a template in here, and I put my survey in. On the survey tab, I click on this box, and I hit the button and say open, and I open my files. That's going to line my survey up. I can put in whatever number it's put in 2 or 10 or whatever I want for my over depth number, and it's going to calculate it for me. When I look at the data, the graph options, in here there's a couple things we can do. I'm plotting single beam data, so I want to plot depth 1 or depth 2, or I want to plot them both. Usually I plot depth 1. Test for gaps. Anyone know what test for gaps does? If your data has a big gap in it, it'll actually connect those 2 points and calculate volumes based on the distance you say the gap can be. So anyone ever edit their data and have a big chunk of data missing? Volumes will only be calculated where there's data. So if there's a big gap of data, and you say the gap's 200, and it finds a gap in there, it's going to say you have a huge gap of data. You'll see your volume will come down and stop, and it'll be a vertical line, and then it'll pick up where the data starts again. That gap of data will not be calculated for volume. You know what I'm saying? I had to stop at the barge, and I picked up on the other side of the barge. It won't interpolate under the barge. We're not going to do that. We don't make up information unless you try to make up information. HYPACK won't do it for you. Template alignment, center line, that's just some ways you can align your template differently. When you go into the View tab, this is where you're going to see your template will show up, your survey data will show up, and see that vertical line I was talking about before? It's not going to extend out. It cuts it off and says that's the edge of the survey. That's where we're stopping our volume. Okay? In here, they've got the numbers drawn up. There's a couple check boxes for labeling, and then they turn on the inflection points. Any questions about what you're seeing on the screen yet? Then we have our printing tab where we can output to DXF or plot to a plotter. You can take all your sections, multiple of them, and plot them on a plotting sheet or plot them out on a plotter, or put them out to a DXF file that you can bring into CAD later. Anyone ever use the plotting or printing function within? Do you like it? Does it work? It's great. It's okay.
Are you talking about the plotting sheet or within this?
Within this. Not with HYPLOT, within this.
Right.
Anyone ever spit out your cross sections okay? Yeah. It does a good job of it. You just gotta you gotta understand what spacing and scales are, and once you get those down, it works pretty good. I ask those kind of questions throughout these lessons. That gives us a better feel of what functions you guys are actually using in the software and what you're not using in the software. If I want to put a lot of effort into doing something, and only one person in the room is doing it, I'm going to ask them how much effort they're using it with and how much of a struggle it is before we fix that for 40 people that don't care.
I use the cross-section sheets through tin.
Okay.
I mean, the line file, and then just do the 2D cross-sections.
In tin model.
Yeah, and then just print it that way in PDF.
Okay. And that's one we talked about in the previous session.
Okay.
With the tin model with the planned lines across the cross sections. And then on your volume report, similar to the tin model volume reports, these are text files. We've actually added the ability to export these to Excel. So you can take those right out to Excel and then do other math on it if you want. It used to save just to a text file. Now you can take them to Excel. If you do a cross-sectional view and you don't have a template in here, you get just the line. You don't see the color fills. If you're ever wondering why you don't see a color fill, it's because you don't have a volume model selected. When I talk about a volume model, there's more volume models in this one than there was in tin model. End area 1. Pre and post dredge volumes. If you have one survey, end area 1, standard HYPACK, those are methods you would do with one survey. Select a method with a 3, end area 3, Chinese end area 3, Philadelphia method, those all let you do pre and posts. So if we look at cross sections and volumes, and I hit the wrong, fingers are faster than my mind. We'll come in here and we'll load A. Come in here and we'll load C. Anyone know what that button's doing? So I've got a whole bunch of files in here in my log file, a whole bunch of files in here in my log file. I'm going to sort them. When you hit that button, what it's going to do is it's going to take the first line and it's going to look in that file. It's going to take the plan line out and say, this is your plan line. And it's going to take the second files and it's going to find which one matches. So you're comparing apples and apples. Sometimes you'll find, and I hit it even though I know these line up, sometimes you'll find that everything looks like it's going to line up. Anyone ever get on the boat and someone else messed with your line files? And all of a sudden one point is different in the line file. Just, they moved one edge. They opened it up and didn't do anything. But they clicked on the point and moved it a little bit, and now your lines don't match up. It doesn't happen very often, does it? When somebody messed with your computer. So we're going to go in here and we're going to choose. We have a whole bunch of these pre and post jeds. Let's go end area 3, over depth 2, and then I want to fill that column. So this is the fill column button. My super depth. You know what a super depth is? It's the depth above over depth or below over depth. And let's go view it. So here we have a volume, our first section. This is the pre-dredge, that's the post-dredge, and we have a bunch of infill that's purple. Down here it's all called all sorts of things. V1 left, V2 left, V3 left. V1, V2, V3. Then you have V1 center, V2 pay, V2 no pay. There's the V2 no pay. Based on contours. It's really quick, it runs really quick. Cross sections and volumes is a really good program for that. I can tell it to align to my template. If I go to my volume report, it gives me data for each one of the sections, broken down by all the different numbers, V2 pay, V2 N pay. Anyone know what all those little V2s and V3s and V1s are? They're areas. NP, it means no pay, V2 pay is V2P. In the PowerPoint that we sent you, or we gave you, is we have a slide like this. People send me volume reports a lot, or send our team volume reports a lot, and they're like, I'm having trouble, my numbers aren't lining up, my volume's off. As hard as it is to believe, when you send us a question, a lot of times we'll get 5 volumes questions in one day, and won't get another volume question for 3 weeks. And it could be a volume question from anywhere, Louisiana to France to wherever in the world, volume questions all of a sudden come from random companies. And then for 2 weeks, a month, we won't hear another volume question. It'll all come at once. And every time it happens, I have to bring this slide up to remind myself what each one of these, like V1 is always above the main template, V2 is always over dredge, and V3 is always the super dredge, and left, right, and center. Center doesn't have anything. No pay would be for the contour stuff. Any questions about that? Okay. Infill report. End area 3 is what I was using for my example. So you can see in here, Y1 is infill for every one of the sections. So in average end area 3, Y1 is any infill that came into any of the sections that it calculated. The red is the and here the green is the post. And you have a delta that's post minus pre-material, and then you have a total paid column. Any questions about any of that? Am I boring you guys to death? No. Cross sections and volumes is a pretty powerful tool. There's a lot of different volume methods in here. Jacksonville has its own pre and post dredge method. Gaps and incomplete coverage. This is one of the things I was talking about a little while ago. And here, you can have internal gaps from here to here. That's where the data was. But that's what it's going to try to connect if you try to connect the extra gaps. You're going to take extra caution with the gaps that span the toes. An external gap doesn't matter to us, right? An external gap is if the edge of the line doesn't go to the edge of the template. We're just not going to calculate anything over there. How many times have you surveyed and couldn't get to the edge of your toe? The slope came up and the ground's there and it's too shallow, you just can't get to it, right? Anyone sit in on the single beam survey and talk about water's edge marks? Josh talked about water's edge marks where you point your boat towards the shore, you hit the F7 button and say the shore's over there 50 feet at 0. And it generates a target out there that you can actually use to, from where you're stopped, it'll generate a slope up to that. Well, an internal gap would be here, where there's material we surveyed, and then we had a bunch of bubbles, and then we got data again. You got to really not, that's an extreme case, right? Incomplete survey areas. So CSV does not create data or extrapolate. In the figure above, the volume is going to be area of 1 and area 2 divided by the distance, divided by the A1 plus A2 times the distance between the two divided by 2 is going to give you the volume. Well, and here we got data all the way across the template, and here we stopped short, but it's going to assume the width of the template is the same. Right? So it assumes your data is the same. That makes sense? You understand why there's an issue there? And here, L3, we stopped. There was a barge in our way. Right? I just explained it's going to use material as far as it has it. So it's going to use that whole area, and that little bit of area. And it's going to take that area plus that area times the distance to calculate the volume. It's going to do the same down here with that one. But you're going to have a big gap of material over here, so you're going to get a volume that's less than the true volume. And the way that should have been handled is to eliminate line 3. If you eliminate line 3, that area plus that area times 100 gives you the volume. That area plus that area times 200 gives you the volume. It's going to be more accurate than that short section that we had in there a minute ago. Everyone agree with that? Disagree with that? Think that's a good idea? All right. It's probably in that extreme case that they showed here, more accurate to leave line 3 out. Now if line 3 gets close to the toe, maybe you leave it in, but with that example, I would take it out. And to check for gaps when you're in the cross-sections and volumes program, you go to graph options and data, you can put in the distance you want and test for it. Anything greater than that number, it's going to pop up and tell you there's a gap that big. That makes sense? Everyone know where that's at? All right. Checking for gaps. What happens if you pre-dredged? Don't cover the entire area. I always love when we have things that say this is not a good option at the start. This is not a good option. We have a couple spots within HYPACK where we did things that customers have asked us for, and to ease our conscience, we put in, make sure you know why you're checking this box. Similar to this one. This one says, I can only where both surveys have data. So if I leave that box checked, which is what I normally would do, I'm only calculating volumes up to there. Full length of before survey. So what happened was, the post survey, for pre-survey went here, post survey stopped here. So it calculated a volume just like that survey went down and out. So it gave volumes in that area that didn't exist. I don't know why you would want to do that. I don't know who would ever do that, but I'm sure we put it in because somebody asked us. We don't normally add features that are crazy when somebody doesn't ask for it. If we had checked the box the way it should have been, this is what the result would have been. We would have only gotten a volume where the 2 lines had data, which is the preferred way of doing this. Any questions about that? All right. So if you did a pre-dredge and a post-dredge, and a per hat. Anyone remember the old rat packs? Got a bunch of these around. I love the rat packs. All right, templates. How much time I got left? I very much apologize. There's so much stuff to go through. So many slides and things we can talk about. We got about 10 minutes left. Again, any specific things you want to bring up in the next 10 minutes, stop me. All right, let's talk about templates. Simple templates. A lot of times we have that option in there to simplify our template points, and we'll tell it we only want 4. You're only going to get a left slope, center channel, and a right slope if you're looking that way. On the other one there, you have the turning basins that you can have. You have different sections of it, complex templates. So, a standard template has 4 points in it, right? Remember when we had, was anyone in there when I did the line files in the last one? We brought a line file up and showed the embedded templates, and there was 11 points. There's 11 points that can make up a standard template. There's top of bank, there's a bunch of different points to it. Non-standard templates, something like this, we've got a bunch of points. Average ender, the program's been modified for AEA 1, 2, and 3, Savannah. All of these will handle the non-standard templates. Other methods will not. The HYPACK method will not handle a non-standard template. The Chinese end area methods 1, 2, 3 can handle any number of template points. They don't break them down. Or there's a section, there's AEA no segments that's listed here. Average end area no segments can handle anything. It can handle any templates, it can do anything you want because we don't break it down by channel, like left, right, center. We just give you the average end area volumes, that's it. We don't care about the material and where it's at. Templates can be made in CSV. You can actually go into the program and give it a DBL and a depth and generate your own template points in the cross sections and volumes. You don't have to make them in the channel design, but you have to make a template per section, right? Templates. So when you run the template editor program within channel or cross sections and volumes, you click on this button and it brings up the dialog. You have to know the DBL and the depth. So you say so many feet down and this is my depth, and so many feet down and this is my depth. It's a very long way to do it, but sometimes you have to build a template per station, especially on beach jobs. Beach jobs sometimes have varying benches that you have to make up. Sometimes you'll have to do it in here. More complicated ones, usually you have like the center channel and a slope. Sometimes you'll have like that mentioned there, complex templates. Searches for the deepest flat area, and that's the center. So in this particular complicated channel, we've got a slope, a bench, a slope, the bottom, and a slope. The deepest bottom is considered the center of the channel. That's how the software is going to handle it. This one's a nice way to explain what you can use. Different number of template points. AEA no segments is one of my favorites because it doesn't bark at anything, it just runs no matter what your template points are. You can use a line file created with a channel design, a line file that has embedded templates in it. You can load that as a template, but it has to be the same line file you ran your survey on. It has to line up those start and end points of your channel. All right. Any questions? Sir?
Your template points, can they have the same X, Y, and difference?
You can do that for a vertical section. I don't see why it wouldn't run for you. It may not give you a volume on that particular section. So because of the vertical wall, there's going to be no volume. There was a problem in the past where that wouldn't work. You'd have to offset the bottom one by 0.1 just so that they would calculate a volume for that face. But I believe that's been resolved. All right, we're done.